For number 37, you have two bikers east, 5 miles per hour. So this particular biker is going east, and I'm going to call that Y. And he's going at a rate of 5 miles per hour. So that's dy, the change in y with respect to time, equals 5. Then another biker, he's going north, and he's going at 12 miles per hour. I'm going to call that x, and his dx dt is equal to 12 miles per hour. And approximately how fast is the distance between them changing? Well, that's this distance here. This distance, they want to know how fast that distance is changing. And I'm going to call that side z, but the distance changing after 3 hours is dz dt. Now, of course, I'm going to do this the long way. One student of mine just did 512. And it wound up being 13, and he got the correct answer of choice C for number 37 as quickly as that. Just did the Pythagorean theorem. I'm going to use implicit differentiation, so I'm going to set it up as Pythagorean theorem, x squared plus y squared equals z squared. And his way was correct. He got the right answer. I differentiate everything. Nothing's constant. The entire triangle is growing. So 2x dx dt plus 2y dy dt. I know what these values are. Equals 2z dz dt, and that's what I'm looking for. I'm looking for dz dt. I can divide everything out by 2 and eliminate the 2's. And then after 3 hours, the x value, 3 times 12, this x value is going to be, he will have traveled 36 miles. So it's going to be 36 dx dt, which is times 12, plus, after 3 hours at 5 miles per hour, this distance here will be 15. So the y value will be 15 times the rate, which is dy dt, which is 5, is going to equal this value, z, times dz dt. Now to find z, I have to do the Pythagorean theorem, which is 36 squared plus 15 squared, and that equals 39 dz dt. Now I have to do some arithmetic. So I add these up and divide by 39, and that should give me what dz dt is. 36 times 12 plus 15 times 5 over 39, and that's the long way of finding out the rate of change between the two bikers. Choice C. Gives me a derivative, and it says that this derivative from 3 to 3.1 is actually 2.377. They already calculated that for me. They want to know what f of 3.1 is. I see here that f of 3 equals 6. F of 3 equals 6. So I'm going to use good old FTC part 2 to solve this. So the integral from 3 to 3.1 of f prime of x dx is going to equal, I'm not going to put that down yet, it's going to equal f of 3.1, and that's what I'm looking for, minus f of 3. Now, f of 3 is going to give me 6, so minus 6. I'm looking for f of 3.1, and it tells me it already calculated that for me. They're being kind, so that's going to equal 0.2377, and I'm just going to solve this for f of 3.1. I just add 6 to both sides, and that's going to give me 6.2377, which rounds to 6.238. For number 39, you can see this is one that I cut and pasted in there from the BC. This is actually a BC question. It's actually an Algebra 2 question, perhaps even an Algebra 2 question, not an Algebra 1 question. They want me to find the infinite sum, and I noticed that it's a geometric series, and it's got a common ratio. The absolute value of the ratio is less than 1, so that means this is going to converge. And this has a really nice zippy way to find the infinite sum. If I throw a 0 in, this gives me 1, 2 times 1, so the first term of this sequence is going to be 2, and I divide that by 1 minus the common ratio. So you take the first term and you divide it by 1 minus the common ratio, and this is actually going to give me 2 over 1 minus negative 1/2. So that's going to give me 1 plus 1/2, which is 3 halves. So that's going to equal 2 over 3 halves. That's going to give me 2 divided by 3 over 2. KFC that. That's going to give me 2 times 2 over 3. So the answer is just going to be 4/3, which in this particular problem is choice A. Volume of revolution, I have y equals 5, and I have this crazy equation of x to the 4th. So I want to solve that for y so I can put it in my calculator. So let's see here. I'm going to add y to both sides and subtract 3x squared and add 3 to both sides. So that's going to give me 5x to the 4th minus 3x squared plus 3 is equal to y. And I want to enter that and y equals 5 into the calculator. And y equals 5x squared. Oh, 5x to the 4th. Don't forget you have to right arrow to get down. Minus 3x squared plus 3. Let me go to my window. I don't know. But it's definitely not going to be 200, so I'll put 8. Y min of negative 6. Definitely not going to be 1,000. I'll put maybe 12. And let's see what that looks like. Here's y equals 5. Here comes the x to the 4th. And I want to get a nicer look at that. That's a pretty good graph. But I'm going to do a thing. So the graph of this is pretty symmetric. I have the big W. I have the y equals 5. There's my y equals 5. I have the big W. And I'm revolving about the x-axis. So the mirror image is going to be at y equals negative 5. And it's going to be a big M, a mirror image M. Sorry. And it's going to be a washer, if you recall doing this. So the formula for a washer is going to be pi integral from, I need to find out where this crosses here and here, r squared, but not, washer is going to be outer radius squared, which is going to be the 5, minus the inner radius squared, which is going to be the equation, which in this case is going to be 5 squared minus, and it's going to be my y1 squared. So I just need to find out what the integral is with respect to x. I need to find those limits of integration. And it should be simple enough. I'm going to hit second calc, intersect. Because I need to find out where they cross each other. Enter, 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 and there it is. X equals 1 and x equals 5. So I think it's safe to say it's symmetric. It's going to be negative 1 to 1. From negative 1 to 1, from negative 1 to 1 of the outer radius squared, which is 5, minus the inner radius squared, which in this case is my y1 on the graph. Oh, incorrect. It's actually my y2. See it? It's my y sub 2. So I'm just going to enter it into the calculator. Don't forget to enter the pi, because it's pi r squared, math 9, from negative 1 to 1 of 25. I could have actually done y1 squared, minus y2 squared, with respect to x, and 98.695, and there it is, it's choice D. It's choice D. Alright, the whole idea behind number 45, well, two ideas, is average value. You asked me for the average value, and that's important. So right off the get-go, I know I'm going to have to divide everything by 6, because the average value from 1 to 7 on the integral is going to be 1 over 7 minus 1 times the integral of 1 to 7 of whatever this all comes out to equal. And the idea of this whole string is that we want to get this to look like that over there. So from 1 to 5 of any function, plus 5 to 7 of that same exact function. Notice, these combine to be the single function. These combine up to render this single function. And that's the whole game plan for a problem such as this that we're going to try. So let's see. Gives me some information. It says from 1 to 7 of f equals 6, but from 7 to 1 of g equals 12. So I'm going to get a little bit of information down here. So 1 to 7 of f equals 6. And from 7 to 1, so that means from 1 to 7 of g is going to equal negative 12. And I'm not being very formal. I'm not putting my f of x dx and all this stuff. I just want to get the idea down on paper. So now, it talks, I'm going to save that. That's going to go in my toolbox. I'm going to use those later. I'm going to need those ideas later to figure out what actual digit this works out to equal. So from 1 to 7 of h of x, 1 to 7 of h of x, dx equals this monster. And notice I have from 1 to 5, 1 to 5 of 2f minus g plus 7 to 5. Well, I need it to be 5 from 5 to 7. I need it to look like this. From 1 to 5, 5 to 7. And they're giving it to me 1 to 5, 7 to 5. So I'm going to rewrite that as 5 to 7. But when I do that, I have to change this out front to a negative. So that's going to give me plus minus g of x minus 2f. Now that negative can distribute across. So this is going to give me a plus again from 5 to 7 of negative g plus 2f, or 2f. That negative goes to 2f, and I'm allowed to switch that up. So notice I have a plus 1 to 5 of 2f minus g plus 5 to 7. Now that I have this idea, I can write it as a single integral like I have over here on the left. See how this is the same as this? So that means I can come over here and rewrite this long, strung out integral with the plus sign as an entire integral from 1 to 7 of 2f minus g. From earlier, it told me that 1 to 7 of f was 6. 1 to 7 of f was 6. So I can rewrite this a little bit. This is going to give me two new integrals. 1 to 7, 2f minus 1 to 7 of g. Let's see. F was 6 and g was negative 12. So this is going to be 6. So 2 times 6 minus negative 12. Remember, 1 to 7 of f equals 6. 1 to 7 of g equals negative 12. 1 to 7 of g equals negative 12. 1 to 7 of f equals 6, but there's a 2 out front. So this is going to give me 12 plus 12. And that's 24. However, I was supposed to do the average value from 1 to 7 of 2f minus g. Average value is 1 over 7 minus 1 out front. And all this equals 24. So it's going to be 1 over 6 times 24, which gives me a value of 4. These are the ones that are replaced that aren't on the video, and they're all the convergence tests. So, for number 3, which of the following diverges? Well, this one's a tough one to look at. However, I can rewrite this as 1 to the n over 2 to the n, which then can be rewritten as 1 half to the n. With all the sigma notation out in front of it, n equals 0 to infinity, and there's a hidden 1 out in front. And this is a geometric series whose common ratio is less than 1. Actually, the absolute value of the common ratio is less than 1. And that means if the common ratio is less than 1 for a geometric series, it converges. So A converges. D or B, I can instantly see that it's going to diverge. And the reason is, even though this alternates, it's going to be 4 minus 1 plus 4 plus 1 plus 4 minus 1. So the 1s are going to cancel out as time goes on. But it's going to be 4 plus 4 plus 4 plus 4. It's just going to continually add up. So right off the start, I can tell that it's going to be choice B that diverges. Choice C converges because it looks like it can be compared to 1 over n squared, and that's a p-series, with the power greater than 1. So if we go down and notice, if that power is greater than 1, it's going to converge. And then this is another p-series. That's what I compared that to. And that's actually more convergent than this one. And this one gets kicked out. This one converges also. Remember which one of these diverges? Nth term test. Basically, we should call this the horizontal asymptote test. And the deal is, what's the horizontal asymptote of 2x plus 1 over 3x minus 1? And that would be 2/3. And the rule is, with the horizontal asymptote, is if the horizontal asymptote is not equal to 0, it diverges. So right off the boom, I can tell that one diverges. P-series, that's going to converge because P is greater than 1. That converges. This is a geometric series with R. Technically, absolute value of R is less than 1. So that's a convergent series. And n squared over 3 to the n, the way to prove that would be the ratio test. Or we can do our little cheat. 3 to the n grows way faster than n squared. So the bottom is going to go to infinity quicker than the top will. So it'll give me some number over infinity, which goes to 0, which converges. Now, do recall, that doesn't always work. I only got away with it because this here, guaranteed, diverges. Number 17, another converges one. Which one converges? Well, this is the same as the one before. We've already done that. That one diverges. Okay, let's see what the power is on the bottom. So it's going to be n to the 1/3. And notice, that's a p-series, but p is less than 1. So that means it diverges. So this one diverges. This looks like a geometric series where r, absolute value of r, is 5/3, and that's greater than 1. So that means that's going to diverge. And this last one can be compared to 1 over n squared, and that's a p-series where the power is greater than 1, and if the power is greater than 1, it converges. So for number 17, the choice is going to be D, converges. Number 21, which of the following diverges? Pi over e, that looks to be like 3.14 over 2.718. That's a geometric series where r is, absolute value of r is greater than 1, so that's going to diverge. I'm done. That's going to diverge, pi over e. This here would be 1 over n, that's a hidden 2 in there, n to the 5 halves, which is 2/5, so 2, or 2.5, which is greater than 1, so this is a p-series, which converges. And notice they're asking me which one diverges. This here is a geometric where r, absolute value of r technically, is less than 1, so that converges. And n over 2 to the n goes way faster than n, so that's going to converge because that goes to some number over infinity, which equals 0. That one converges also. Hopefully. I can only get away with it because I know that one for sure. And actually, to realistically test this, I would have to use the ratio test. 22, I want to find the sum. It's a geometric, and r, absolute value of r, I should use the lowercase. Absolute value of r is less than 1 because it's 0.9. The first term, if I throw a 1 in there, is going to be 2 times 0.9, 2 times negative 0.9. Let's see what that is. 2 times 0.9 is 18 with 1 decimal negative. So the first term is 18, negative 1.8 over 1 minus the common ratio, which is negative 0.9. So those are going to add. And I guess this is going to give me negative 1.8 over 1.9 equals negative 18 over 19. I hope that's... And there it is! Choice D. The decimals will go away and it's going to be negative 18 over 19. I didn't even need a calculator. Number 28, find the sum. I can see it's a geometric series. The first term, if I plug in 1, is going to be 6 times 0.5 to the first. So my first term is going to be 3, and then I put that over 1 minus the common ratio, 0.5. So that's going to equal 3 over 0.5, or 3 divided by 1/2. I can't see that. That's going to give me 3 times 2 over 1. So this converges to 6. Well, the infinite sum is 6. Another sum problem. Notice the sum problems are usually going to be geometric. It does converge to a sum because r is less, absolute value of r technically is less than 1. So my first term, when I throw in a 0, is going to be negative 1/2 to the 0, which is 1. So my first term is going to be 2 over 1 minus the radius, or I'm sorry, the common ratio, which in this case is negative 1/2. So 1 plus 1/2, 2 over 1.5, sorry, or 2 over 3 divided by 2. 2 times 2 over 3, which gives me 4/3 as my sum. Choice A is going to be my sum.